Hi everyone and welcome to the next video in a series of tutorials for the CAD NX practical course. And as already promised, today I will get into the thread function, which in my opinion again is not important for the exam because I've never seen it, but who knows, maybe that will change. So in that case I will show it to you today. It's no big deal anyways, but it's one of a set of functions that used to be more important in NX when we started this course back in whenever it was. I wasn't here. But now, after the update especially, this function is kind of depreciated together with some other functions. And one of those I will show you later on too, because that's more important, the other one. So because of this fact that they are not as that they don't want you to use them anymore, I would say, Siemens, you can find it as easily and have to search it up here, which is the easiest way, but yeah, you see it's a little bit hidden, but we can find it here. And now it's only important that you have set this up here to detailed. That's the way. That's where you can mess up. But if you have it on detailed, it should work. Symbolic usually doesn't work, and I don't know why. So let's choose detailed, and now it only wants us to select a cylinder. Of course, you need a cylinder first that you want to thread. I have mine here. It has a radius or a diameter of 20 millimeters, and I'm selecting it. And then it will also, okay, it already shows how it would look, because now, since our cylinder is 20 millimeters, and we have a thread standard metric course selected right here, the first one should be selected for you too, I guess. It searches for the thread size which matches the cylinder best, which in this case is M20 times 2.5. That's because we had this option right here on, okay? And the handedness you could still change, but usually that's not asked of you anyways. But one thing that you have to look out for now, and here you just have to look at the thread and see whether it makes sense. Well, in our case there's no head, but let's say the head should be up here of the thread. Then down here should be the tip, right? And is it that way right now? Yes, it is. And how can you see that? Well, down here you see that the start is looks like that. I don't know how to describe it really, but you'll see the difference if we see the end of the thread, which looks like this. Yeah. So as you can imagine, screwing it in that way would be hard, and that's the direction. So the arrow that specifies the direction, you can see that here. It's yellow. If I reverse it, it gets more clearer, I guess. No, I can't. Okay, I can't reverse it because the start object, it was automatically selected to be down here. And if I let me cancel it and try it again, choosing the other one, the other side. So let's first select the start object to be up here, and then the cylinder. And now you see it's the other way around. Now down here's the end, and there's the beginning of the thread, and the yellow arrow is right here. Okay, but we wanted the other way around. Do we want it? Yeah, let's do it the other way around again. Oh, shouldn't have clicked OK. So one more time. Then you have seen it 3 times. Make sure it's detailed. Select the start object. Start means where the tip of the screw would be. That can be confusing, but yeah. If you will see if it's the wrong way around, then just do it the other way. Exactly, and that's it. And one more thing that we can do, thread limit down here, which is set to full for me. I can set to value, and now I can say, okay, I only want, like, let's say 40 millimeters of a thread, and the rest shouldn't be threaded. And then it looks like this. And now it might make even more sense why this is the end. Okay, and now that was everything you need to know for a thread. Make sure before your cylinder has already the right dimensions, and then you just have to apply this function. It's pretty neat. And if you need to do a thread, you don't get around it. Another function that was in one of the parts is groove. And that should make a groove. I hope you know what that word means in English. In German, I don't know it, I realize right now. Kerbe, I think it is in German. It's having a little... let me show you how it looks. I'm pausing a second. That would be easier, I guess. Okay, so I'm back, and that's the groove. All right. So that's what we want to do. And there used to be a function, and it's still there, that does exactly that, but that function looks like this. And I think it's a mess, and that's why I refuse to teach it to you. And also, I'm pretty sure that NX doesn't want you to use it anymore, because it's one of their legacy functions. And I think there's a elegant way how to do that, and I'm going to show you that now. So let me quickly delete this again, and let's say the requirements for this groove are that it's 5 millimeters from the top, and that it should be 5 by 5 millimeters. How would we do that without the function? Well, the idea is simply sketch the cross-section of this groove here, and then revolve it one time around the whole circle and the whole cylinder, and delete the material that it revolves. If that's not clear to you, I'm showing you how I do it. So first we need a sketch, and here we need to choose one of the axes that is exactly one of the planes, sorry, that is exactly cutting our cylinder in half. Because I luckily did it or constructed this thing like that, my coordinate axes are there. I could simply pick them, but I want to show you how you can create such an axis if you don't have one, and this is somewhere else. So you want to use the datum plane function that we already know. And now we can, my idea, and I actually don't know how to do it right now, is to just lay the plane anywhere, doesn't matter really, on the surface of the cylinder, okay? Just have to find out what I can use. Okay, and I could... I could just do it. Let me do it again, sorry. I can just do it with invert, so basically the basic option. Okay, so I'm selecting invert. If you are at the same point as me and you don't know what to use, sometimes you could just try, and usually start with invert because that's kind of the intelligent method. So I'm using revert. It puts a plane like this. That's nice, but we can't sketch on this one, of course, but we can simply now make a datum plane at a distance, the second option, from that, and you might have already guessed it, at half... Oh, that was full. At half the... or at the radius, so at half the diameter, okay? Because then we have it exactly halving the cylinder. And now we can sketch on this plane and make our rectangle anywhere. You know how I like to do it, then say the 5 millimeters distance that we need. Here we can do yes. Ah man, that wasn't that nice. Never mind. If I'm doing the distance here, that should be 10 because that's our diameter, right? It should be even only 5 because I said 5 by 5, right? And now the height should also be 5, and that should be also 5, obviously. 5. Okay, so it's a 5 by 5 square with a distance of 5 to the end, and we are rotating that 5 by 5 square that we can't really see right now because we sketched somehow inside, and we will rotate that now around and delete. And I think by now you should have realized how that will work. Sorry, selected the wrong one. I'm clicking on revolve, selecting the sketch, specifying the vector, which is the middle axis of our cylinder. You saw I just selected the cylinder and it automatically took its middle axis. That's pretty neat. You can also just pick the middle axis if, for example, the Z axis is in the middle. Then click on OK, and now you see we rotated it around and we deleted the material that we swept, and now we have our growth. So that one, definitely something, if you haven't figured it out yourself before, maybe you also found a different approach. Another one, maybe even easier, would be at 5 millimeters distance from up here, create a plane. The other direction, 5 millimeters. And then on that plane, sketch a ring that is exactly 20, or even just a ring of 10 because the growth should be 5. Let me delete our previous approach. Now we have that ring, and now we use extrude in the distance of -5 because it should be 5. And now we choose something that I think was never used before, but I taught it to you. And that's intersect, but that, okay, I just realized that won't work. That only leaves the middle right here. So back into the sketch, we need to do both circles. That one with 20, and then extrude it -5, and this time we're choosing subtract simply, and you can see how that does the same. Okay, I hope you understood both of the approaches. Do whatever's easier for you. I would say in that case maybe it was even the second one, but sometimes this growth needs to be round, and then you can't do it like that. Then you need to do a sketch, but round the bottom right here. I hope you know what I mean. And if that's round, then you can rotate it around and it will be a round cutout. That you can't do with the extrude approach, okay? So I would recommend always use that one, and then in case in the exam you need to do a round one, you have already practiced it. Maybe not with round, but with square, but it's then the same approach. Okay, and last thing, if you ever come, one more of those depreciated functions is slot, I guess it was called. And I think that's not even, well, it's still here, it's slot legacy, and it has been replaced by a lot of different functions that I don't want to get into. And slot would be something, and that was also something that was in the same exercise where this groove was in. Slot would be making a little slot in this cylinder. But I think also that you can solve more easily without having to learn an additional function just by extruding. First thing is you need this plane right here to draw the slot onto, but now you can sketch on this plane. I'm just doing it freehand now. Create the shape of your slot right here, and then you extrude like -2 or something, and you see that's the slot. So no need to learn an extra function for that, definitely not 4 or 5. And yeah, I'm not feeling good teaching you a function that the program doesn't want you to use anymore because it's depreciated. Okay, so that's it for this video, basically about the older feature functions of NX and how you can get around them. I hope you learned something, and I hope I could also motivate kind of this way of thinking about workarounds for you, because even in the exam, if something or something you haven't seen before comes up, that might happen, but it's not that extremely probable if you have done all of the parts. But still, if something comes up where you don't immediately know, then you have to have developed this feeling of how to work around certain issues. And working around certain issues, 99% of the cases works with extrude and revolve. You can do almost everything, if not everything, that we need. The only limitation, of course, is something like this, threading and sweeping along guide, because that definitely is something else. And I mean, you could do threading with sweeping along guide, but that would be extremely, unnecessary. So I hope, that you learned a lot again, and wanna say thanks and bye. You will see probably one more video now for this course. Bye.